I just finished these two stop-motion armatures, which were commissioned by another short film production. Nothing too fancy about them, but while working on them I came across a very neat little mechanism which makes rigging of stop-motion puppets way more comfortable. I did not invent it, someone told me about it, but it seems it's not a very well-known mechanism, and so I thought I might as well tell you about it. Okay, so a rig is basically an external contraption which helps the puppet to hold a specific position, like flying or jumping, or just to stabilize it when standing or walking, for example, to make animation easier. And yeah, usually there are multiple attachment points on a puppet where you can attach a rig, usually in the hip, on the side and front and back, and the same in the chest area, like below the armpits and in front and back of the chest. So yeah, you can always hide the rig behind the puppet, basically, that's the idea. And there are different techniques to attach a rig to a puppet. The easiest one is just to have some threaded holes where you can insert a threaded rod. But those can be very fiddly to get in, and also they're prone to getting loose because they have no rotational resistance, basically. So the preferred way usually is those square holes or pieces of square tube on the puppet, and then you can insert a square bar which is either clamped by a little screw on the side of the square tube or just holds in by friction. But yeah, friction is not that reliable, and if there's an external tiny screw on the side of the rod, it's very fiddly to attach, and especially if you're doing it in the middle of an animation, you want to have as little interference on the puppet as possible, of course. So that's where this little bar comes in handy. So the idea is basically it's a square rod, and you can very easily insert it into the puppet, and then if you tighten the screw down here, the rod will expand inside that tube and clamp itself inside the puppet, and this makes for a very rigid connection. And if you want to get it out again, you just loosen the screw a tiny bit and it will just come out without any friction, basically, very loose. So yeah, I think that's extremely useful and a very neat solution. So yeah, how does it work exactly? So the mechanism is actually quite simple, just consisting of three major parts. First, there is this square bar with a hole right through its center, and then there's a threaded rod which fits inside that hole, and the threaded rod has also a piece of the same square bar soldered to its end, and both square bar pieces have a 45-degree angle on their ends, which perfectly match together, and so together they form kind of a sloping action. Once the threaded rod is pulled, the two pieces slide on each other and basically expand in that movement. And that's exactly what the nut does once it's tightened. And tighten it, and you can see a very minimal movement on the tip, and yeah, you can see the entire square assembly gets wider. And to connect this mechanism to your main rig, you could either just clamp it on the outside diameter of the main square rod, or I have also machined a little adapter piece which just slides over it and can be tightened at any position with this side screw, and then it has a 6mm ball which connects to all standard rigs. So if you want to build a mechanism like this yourself, the most challenging part, I think, is the very long straight hole through the entire square bar. So I used a very long drill on my manual mill, which worked quite nice, but if that's no option, then you can also use one of these ready-made hollow square tubes and just solder some solid end pieces to it. So you only have to drill a tiny bit and still have a nice solid section for you to produce the 45-degree slope. That one I also machined on my mill, but I think it would also be possible to just file it manually. And other than that, it's really very simple. Just have to make sure you get square bars which actually fit inside the matching tubes. The tubes usually used in stop motion are imperial units, so I think the inside diameter is like 5/32 inches, which is quite an odd measurement. Turns out to be 3.96 millimeters. But as it happens, if you buy a 4 millimeter brass square rod, they usually come a bit undersized, which actually fits inside the tubes quite nicely, but it really depends on the brand. So another thing which I think can be quite challenging is actually soldering the shoulder and hip pieces on those armatures. So yeah, on these puppets for the first time, the hip and shoulder pieces are actually just one big piece of brass, which includes all the square holes. And for that, of course, you need a square drill, which is actually called a square broach and doesn't rotate. So that's a really neat little tool. First you drill a round hole and then you insert this rod and press it through that hole with a lot of pressure, with an arbor press. And it leaves a very clean square section of exactly 5/32 of an inch. And yeah, it's quite an advanced tool for my standards, but yeah, I'm very glad I can make shoulder and hip pieces from one piece now, because it makes soldering much easier, and also the blocks are much more rigid that way. So for the actual broaching, I'm using a manual knee lever press, which helps to apply the force very gentle and exactly at a right angle, which is very important for this operation. And after broaching all those square holes in the hip and shoulder parts, I just machine away all the brass which is not strictly needed to save some weight. And the final result is usually about the same weight as a similar solution with square tube pieces. And one final side note, I also tried out a new foot design on these armatures. They're not the most pretty thing. I might make some nicer ones for the shop at some point, but from a mechanical point of view, I think they are very elegant. They have just a very small 3mm rod as the main hinge point, which is soldered to the tip of the toes. And then there's a simple clamping mechanism on the backside of the foot, which gets clamped by a screw from the low side, from the sole of the foot, which remains accessible even after the entire foot is enclosed in silicone or has a shoe on or something like this. So it's readjustable and it functions very well, and also it's very flat profile, so it can also be used in very small scale armatures or for bare feet characters, something like this. So I think that will be the design I will use on future feet only. And yeah, on these armatures I tried out a lot of new techniques, and yeah, I learned a lot in the process. Okay, I hope this was helpful, and in case you're interested in getting a stop motion armature or one of these rigging rods from me, then please check out my webshop at vfkinetics.de or just write me an email. And if you're interested in stop motion news in general, then also check out my YouTube channel for more interesting stuff and consider supporting my work on Patreon, which really enables me to play around with all sorts of ideas and make these videos, and mainly to finish my movie project An Unbound Clockwork, which I'm working on for over 10 years now, but we just crossed the 80% mark, which is quite a milestone. So if you want to help us cross the finish line finally, please support the project on Patreon. It's greatly appreciated. Thank you all so much and see you next time. Bye bye.